several pages in your IReady book, and I'm going to go over them pretty quickly because when we're comparing fractions, we're going to use the butterfly method. Now, your book may talk about using number lines to compare them, and we may use some number lines, but pretty much we will be butterflying our fractions, okay? Whoops, didn't mean to do that. So let's start on 186. It's showing you how you can compare fractions that have like denominators. So the rule is if you have the fractions that have the same denominator, so let's take our pencils and let's circle same denominator, okay? If they have matching denominators like 6 and 6 here match, you can simply just look at your numerator to know which one's larger. So we have 2 6 and 5 6. Since our denominators match, they're the same, we're going to look at our numerators and we can see that 5 is larger than 2, so 5 6 would be our greater fraction. But what I'm going to have you do, no matter if the denominators match or not, is we're going to butterfly. Bottom up, 6 times 5 is 30. Bottom up, 6 times 2 is 12. So 12 is smaller than 30. So again, less than symbol. Butterflying will work on everything regardless on if their denominators match or not. Now, if you have different denominators, but the same numerator, the rule is the more you cut it, the smaller your pieces become. Okay? So since 3 6 and 3 4 have the same numerators, the smaller the number, the bigger the pieces, because I didn't cut it very much. So we know 3 4 would have to be the larger fraction. But again, we're going to butterfly them to check it. 6 times 3 is 18. 4 times 3 is 12. 12 is smaller than 18, so less than. So again, we're not going to worry so much about the rules, even though we are going to put the rules in our notebook. We're going to be concentrating on the butterfly method. So let's go ahead and do the reflection. It says, explain how you can use unit fractions to help you compare fractions. We're going to say the size of a unit fraction will show us, I was going to put help, but I like show better, will show us the sizes of our entire fraction. Pictures will help, and you can absolutely draw pictures, but our main focus is going to be the butterfly method, and that will tell us which fraction is the biggest always. So we're going to use that. Now they may give us pictures like you see on page 188, and we can absolutely look at those to determine which fraction is larger, and a lot of times you'll be able to tell, but we are still going to butterfly. Write the fractions shaded below each area model. So 2 are shaded, 3 total, so my fraction is 2/3. 1 is shaded, 3 total, my fraction is 1/3. Circle the fraction that is greater. I want you to butterfly. Even those folks that are sitting here and telling me, yes, I already know. You absolutely probably do know, but we need to practice multiplication facts anyway. 3 times 1 is 3. Other side, 3 times 2 is 6. 6 is bigger than 3. So therefore 2/3 should be circled. And I know you could tell by looking that this has more shaded red than this one, so it's the bigger fraction. But when we butterfly, we know for certain. Number 3, write the fraction shaded below the first model. So that fraction would be 1, 2, 3, 4, 5 shaded parts, 6, 7, 8 total pieces. So 5/8. Shade the second model to show a fraction greater. So to be greater, I need to shade more, right? I need to shade more pieces to be a greater fraction. So if 5 were shaded, I just need to shade at least one more than 5. So I'm going to match it just like it is over here. Those 4 pieces plus this one. And then I'm just going to shade one more piece extra. So my fraction is not 5/8, but 6/8. And I know 6/8 is more because it has a whole extra piece shaded in. So pictures will help us. Number 4 and 5, still using pictures to determine greater fractions. Write the fraction shaded below each area model. Circle the fraction that is greater. Now this time our pictures aren't very helpful. Butterflying will help us. 1, 2, 3, 4, 5, 6 pieces. 1 out of 2 pieces. I can't tell really well which piece is bigger. I think this one's bigger, but just to be sure, let's butterfly them. 6 times 1 is 6. 2 times 1 is 2. 2 is smaller than 6, so 1/6 is smaller. So we're supposed to circle the greater one. It is definitely 1/2 because 1/2 had the bigger answer on its side. Number 5, write the fraction shaded below each area model. Circle the fraction that is less. So we got to read our directions. We've been doing greater. Now it wants the smaller one. I see 2 are shaded. 2, 3, 4, 5, 6 total. 2 are shaded. 3 total. Let's butterfly them. Remember this time we're looking for the smaller side because it says less. Bottoms up. 6 times 2 is 12. Bottoms up. 3 times 2 is 6. Which side has the smaller answer? The 2/6 side, right? So we're going to circle the smallest one. And by those pictures, you can tell that that side has the least amount that is colored in. Sure. All right, number 6. Write the fraction shaded below the first area model. Shade the second area model to show a fraction that is less, but has the same numerator. So the first model has 1, 2, 3, 4, 5 out of 6. They want our numerators to be the same. So we still want 5. But we don't want 6 pieces. So I need to cut it, right? So if I cut it, let's cut it 2 more lines. We're still going to shade 5 pieces. I'm going to use blue just like they did. 1, 2, 3, 4. I'm still shading 5 pieces, but what's my denominator now? It's not 6. I changed it, didn't I? To 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's now 5/16. Explain how you know the fraction you shaded is the lesser fraction. Well, I could butterfly and prove it, but I can see that less of the whole rectangle is shaded. So that's what I'm going to put. Less of the whole rectangle is shaded. I shaded less. Even though I still shaded 5 pieces, those pieces were a whole lot smaller because I cut it up more. Right? Page 189. We've got some writing to do. Look at your answers to problem 2 and 3. Explain how to use unit fractions to compare fractions with the same denominator. These are those rules we talked about. But again, I'm not real concerned with the rules. But yes, we're going to write them down. But if you butterfly, you're going to know which fraction's always the greatest, and you'll be able to figure out which one's less by butterflying or if they're equal. So unit fractions with the same denominator. If you have the same denominator, we when you have the same denominator, I'm going to put when you have the same denominator, the larger numerator is the largest fraction. You just have to look at the top numbers if your bottom numbers match, because the pieces are cut into the same sizes. Then you can just look at the top. Look at your answers to problem 4 and 5. What do you notice about the numerators and denominators in each pair of fractions? How is the different, I can't read it, sorry. How is this different from the numerators and denominators of the pairs of fractions in problem 2 and 3? Well, I don't remember 4 and 5. Okay, on 4 and 5, you had the same numerator but different denominator, so that was a difference. Let's tell them that. Okay, numerators were the same with different denominators. Different denominators. The larger the denominator, the smaller the parts or pieces become. So when your numerators are the same number, the bigger denominator is actually your smaller fraction because you've cut it into smaller pieces. The more lines I draw, the smaller those pieces keep coming. Explain how to use unit fractions to compare fractions with the same numerator. We're basically going to say this again. The larger the denominator, the smaller the unit is. The unit fraction, let's say fraction. Yes. The more we cut it up, the smaller those pieces become. So if our numerators match, the biggest denominator will actually be the smaller parts because you cut it up more, smaller pieces. So we're comparing 3/8 and 3/6. Both fractions have the same numerator. They both have a 3. Can you tell which is less? Because the bigger denominator, the more you cut this one was cut into 8 pieces and this one was cut into 6. So 8 pieces would be smaller. We could also butterfly that to prove it. You would get 24 over here and 18. So again, this side would be smaller. So the 8, let's see, both fractions have the same. How can he tell? The largest, again, we're saying the same thing. The largest, the denominator, the smaller the fraction. 3/8 is less than 3/6. The picture that's cut into 6 pieces, those are going to be bigger sizes. That fraction that's been cut into 8 pieces, those pieces are going to be smaller. So when your numerators match, the bigger number at the denominator is going to actually be the smallest pieces, the smallest fraction. But I don't want y'all worrying so much about the rules. Just butterfly them. All right, so that's what we're going to do to answer these. We will be butterflying them. Now, number lines help in comparing fractions also, because you know if you're closer to 0 that you're a smaller fraction. If you're closer to 1, you've got to be the bigger fraction. If you're right in the middle, then you're a half, right? But again, we can simply butterfly these to know for sure. They want us to circle the one that is less. Read those directions to know which one to circle. We want the one that is less. So I'm going to take 3/8 and butterfly it with 3/4. 8 times 3 is 24. Other side, 4 times 3 is 12. 12 is smaller, so 3/8 is less. We wanted the less, so 3/8 would get the answer. This one we want the greatest one. So again, 4, 6, and 3, 6. 6 times 3 is 18. Other side, 6 times 4 is 24. 24 is greater than 18, so 4, 6 is the greater fraction. It's also closer to 1, and it's almost to the end of that line. So butterflying, or then you can use the number lines. Number 12, we may change directions on this. It says draw an area model or number line to show 5/8. Find a fraction with the same denominator that is less than 5/8. So since we're using the same denominator, we can use one number line, can't we? So let's do the number line on this one. So remember, we have to start at 0. We have to end at 1. Our denominator is 8. So I need 4 in the front, 4 in the back. 1, 2, 3, 4, 5, 5. Oops, almost passed it. Here's 5/8. We want a fraction that is less than. That means our fraction needs to be closer to 0 to be less. It should be closer here. So anything down here, you could do 1/8, 2/8, 3/8, or 4/8. You pick whichever one here. I'm going to go with 3/8 just because it's kind of that's there in the middle. I don't know why. And the reason I found it is 3/8 is closer to 0 than 5/8. So 3/8 is less than 5/8. 3/8 is closer to 0. That makes it less. If it's closer to 1, it's greater. Closer to 0, you're less. Number 13. Mario painted 2/6 of the wall in his bedroom. Milene painted 2/4 of a wall in her bedroom. Both walls are the same size. Explain how you know who painted more of their wall. Simply, we can butterfly this. I do notice that their numerators are the same, so my rule tells me if we have the same numerators, the more I cut it, the smaller it becomes. So, but that rule tells me 2/6 is smaller. But I'm going to butterfly them anyway to make sure it's smaller. Remember, we want we want more, don't we? So we were looking for more. I said smaller. So if this one's smaller, then 2/4 would be my more. But let's butterfly. 6 times 2 is 12. Other side. 4 times 2 is 8. We want the more, so we want the greater one. 12 is greater, so 2/4 would be greater. 2/4 is more because we're going to put the rule because 4 parts are larger or bigger than 6 parts. When your numerators are the same, the only thing the rule says to do is look at your denominator. The more you cut it, the smaller your pieces become. So we wanted the larger section, so we need to pick the denominator that had the smallest number because those parts would be so much bigger. Or simply butterfly them. To me, that's just so much quicker, and it helps us on our multiplication facts. 14, Jace and Leanna each baked a loaf of bread. Jace cut his loaf into halves, and Leanna cut her loaf into thirds. I already see a problem. The models below show their loaves of bread. I see a huge problem. Jace says they can use their loaves of bread to show 1/2 is less than 1/3. First of all, let's butterfly these. He's saying half is less. What happens when you butterfly those? Problem. Half is greater, isn't it? Because 3 is greater than 2. So she says that they can't tell. Who's correct? She's correct. What's wrong with their pictures? They're not the same size because their whole loaves are not equal. You cannot compare them. Remember, we have to make sure that our holes are the same length before.